Okay, I'll repeat again. Fluid flow is causing by this force. Four type of force. First is the tensile force. It force the force that pulls the fluid. So it's from the end part of the flow. And then the compression force, it's compress the fluid from the beginning of the flow. And both are increasing. If the value of the force are increased, then the velocity of the fluid is also increase. Ya. Jadi kalau nilai dari gaya tarik maupun gaya dorong atau gaya tekan itu meningkat, maka kecepatan alirnya akan meningkat. The other types is shear force. It shears, menggeser the fluid. What is the difference between tensile, compression, and shear force from the direction? Do you still remember?
Sorry, sir, what's your question, sir?
What will be the difference in terms of direction between tensile force, compression force, and shear force? Is there any differences in the direction?
I think there is, sir.
What is the differences?
Maybe for compression force, it's compression on the fluid. So maybe if the fluid is going from left to right, it's from top to bottom. For shear force and tensile force, it's going almost the same direction, I guess.
Yeah. So if you have pipe, then fluid is flowing this direction from left to right. So the tensile force, the position is here. It pulls the fluid. The compression force, it compresses the fluid, mendorong atau menekan. But the direction is the similar. The direction of the force will be the same direction as the fluid flow. So this is the tensile, this is the compression. Just the position is different, but the direction of the force is the same. How about the shear force? Shear force here. So it shears, menggeser, it shears the fluid. The direction of the force is also the same. The difference is how to calculate the value. How to calculate the value, you must see, because force will be this one, right? The differences is in calculating the area. For the shear force, it will be the area, cross-sectional area, perpendicular to the direction of the force. For the compression force, is also the cross-section area, perpendicular to the force. But for the shear force, it will be the surface area, this one. But the direction is the same. Just how to calculate the value in terms of area is different. Both for the compression and tensile is perpendicular, or the cross section. This is the cross section. This one also cross section. But for the shear, it will be the surface of the pipe. Luas selimut.
Sir, I have a question, sir. You said before in the manometer that F in the tensile force, the pressure there cannot be the same as the one before, or else the liquid can't move, right, sir? Or if the one in the compression, the pressure in the compression is lower than the one in the tensile, it will go the other way, right? Wouldn't the pressure be different, sir, in both sides of the pipe, sir?
Yes, of course. So if the flowing, the the flowing fluid is not steady. It's not, it is not steady since maybe the pressure from this part is higher. For example, you said it's higher than the tensile force, right? So the flow will be faster at the beginning, right? But actually it will comes to the steady condition. Ya, kan arahnya sama. The direction is the same. So if the compression force is much higher than the tensile force, then there will be differences in the velocity throughout the pipe. Until certain condition, it will be steady. Steady means the velocity profile or the value of the linear velocity will be the same. As long as there is no other force acting upon the fluid, right? Is that answering the question?
So, sir, the pressure, even though the pressure is different, it will go up to a certain velocity until it becomes constant, gitu, sir.
As long as direction is the same.
Alright, okay.
Kecuali, unless there are some other force that have that kind of direction, which is friction force. Friction force atau gaya friksi will experience by the fluid since the fluid have friction with the inner surface of the cylinder. The direction of the force is backwards. Ya, jadi arah gaya friksi itu ke belakang. It will backwards, so the higher the friction force, the lower the velocity. It will reduce the velocity. And how to calculate the friction force is actually same as shear force. The area will be the surface area of the inner part of the cylinder, of the pipe. So normally, during the fluid flow, we only consider compression force because we rarely pull up the fluid. We normally just compress the fluid and the friction force. Ya, biasanya fluida itu ngalir karena ada yang dorong, jarang ya, susah untuk menarik fluida walaupun bisa, dan karena ada gesekan. Any question first? Okay. This one about dimension and unit. Please don't forget about the dimension and conversion. Okay. From the fluid flow, what can we observe is flow regime or flow pattern. So based on the fluid velocity inside the pipe, the fluid will experience certain flow regime or flow pattern, regime aliran atau pola aliran berdasarkan kecepatan ya. Jadi berdasarkan kecepatan fluida mengalir di dalam pipa, maka akan bisa berbeda profil atau pola atau regime alirannya. The most two extreme one is laminar flow and turbulent flow. Laminar flow happen in the very low flow rate. It will show like this, the profile of the velocity. It will show like a very smooth layer by layer flow. Ya, jadi kalau aliran laminar itu Anda bayangkan ini terjadi pada kecepatan yang relatif yang cukup rendah. Anda bayangkan alirannya seperti aliran lapis demi lapis. So like one layer near the walls, and then the other layers below, and so on. There is no mixing perpendicular to the axis. Ya, jadi tidak ada yang ke sana, tidak ada yang ke sana, itu tidak ada. The other extreme is the turbulent flow. Turbulent flow happen in a very high flow rate, pada laju alir yang sangat tinggi. So if in laminar flow it's really smooth layer by layer, in this turbulent flow there will be no layers. So like, and some part is faster, some part is lower, and then there is some backwards flow, and etc. And how to characterize and how we can differentiate some flow is classified as laminar or turbulence, we use parameters called Reynolds number. So Reynolds number can be used. You can calculate the value to check whether it's in the laminar flow or turbulent flow. What is the formula of the fluid Reynolds number? You can use this equation. So the Reynolds number is actually density of the fluid. This is density, fluid density. And then pipe diameter. And then fluid linear velocity. And fluid viscosity. So by using this formula, you can check the units. It should be without unit. So there's no dimension. There is no unit for Reynolds number, just number. Right? So the D, this is pipe diameter, is the internal pipe diameter. And basically, when you check the formula, Reynolds number, actually it representing the ratio or correlation between inertial force and viscous force. What is inertial force? Inertial force is force that influenced by the velocity. Ya, jadi gaya yang diakibatkan oleh gerakan fluida, karena fluidanya punya kecepatan.
Sir, I don't understand the inertial force and viscous force, sir. And also in the Reynolds number, what's the difference between fluid linear velocity and the fluid velocity, sir?
Okay, I'll explain to you. Yeah, the inertial force is the force caused by the velocity. It means the higher the velocity, the higher the force. But the viscous force is the force that menahan itu apa? Bahasa Inggris. Jadi viscous force adalah gaya yang menahan kecepatan fluida. Why so the initial force will increase when the velocity of the fluid is increased. Ya, semakin cepat kecepatan fluida, maka gaya inersianya akan semakin cepat. Atau dibalik, semakin besar gaya inersianya, jadi makin mudah bergerak. It means when the inertial force is higher, the fluid is easier to flow. But in contrast, for the viscous force, the higher the viscous force, it means the fluid is difficult to flow. So it influenced by viscosity. You still remember, right, the definition of viscosity? Viscosity is the parameter that quantify the easy or not easy that the fluid can be flown. The higher the viscosity, it means the fluid is difficult to flow. That's quantified viscous force. So it is the ratio. So in Reynolds number, actually you quantify the ratio. Quantify the ratio means you compare which one is higher, which one is more significant. If the inertial flow is less significant than viscous flow, right? Kalau gaya inersianya itu jauh lebih rendah daripada gaya viskosnya, then the fluid will be difficult to flow. Ya, jadi kalau gaya yang menahan itu lebih signifikan daripada gaya yang menggerakkan, maka alirannya akan lebih tertahan. Okay, that's why when the Reynolds number is small, small means the viscous flow is significant. So when Reynolds number is small, so it becomes laminar. That's why the fluid pattern will be layer by layer, because the effect of the viscous flow, viscous force is significant. Ada gaya yang menahan aliran fluidanya sehingga alirannya mengalirnya teratur, layer by layer. But if the Reynolds number is high, it means the inertial force is more significant than the viscous force. It will become turbulent. Menjadi tidak teratur alirannya. Kecepatannya tinggi, alirannya tidak teratur. Gaya yang menahan itu sudah tidak signifikan. Fluidanya yang larinya kemana-mana, seperti itu. Okay, you ask about the linear velocity. Linear velocity is the velocity, the normal term velocity, meter over second. This is linear velocity. Okay, so from this equation, actually you can replace mu over rho become this one, right? Because this one is mu over rho. Or you can use fluid mass flux. Fluid mass flux is the mass rate kilogram over second divided by square meters. Ya, tolong dikoreksi di bagian ini. Please correct this part. This one should be this one. Mass flux will be d rho times E. The unit of the fluid mass flux is mass rate, mass flow rate, kilograms per second, divided by square meters. Any question first?
Sir, what does mass flux mean, sir?
It means, what do you mean? It means how you quantify the flow rate or any types of rate. In this term is mass flow rate divided by certain area. So normalized into certain area.
I don't get it, sir.
I don't know how to explain in more simple way, because definition of flux, any type of flux, because later if you study about the
Electricity
not only electricity, heat
and
transfer,
magnetic field.
heat transfer, you sometimes will encounter heat flux. So flux means rate, but divided by area. This another terms to quantify rate, but already divided by area. It already normalized with area. So it will be rate unit divided by area unit. It's called flux. Jadi dalam bahasa Indonesia ya, laju yang menembus luasan tertentu.
Oke, get
Kalau
it, sir.
massa ya berarti massa yang menembus luasan tertentu. Kalau panas ya panas yang menembus luasan tertentu. Jadi laju per area. So mass flux will be mass rate or mass flow rate, kilogram per second, for example, the SI unit divided by area, squares meters. So depending on the information that you have, you can calculate Reynolds number. The basic equation is this one, rho du over mu, but you can change into another parameters. But the unit should be the same. It's dimensionless. Okay.
Okay, sir. I get it, sir.
Now we we will compare the differences between laminar flow and the turbulent flow. So for the ideal laminar flow, the profile will be like this. This one. It means near the wall, since the shear stress is very, very high, the friction between the top layer and the most top layer and the most bottom layer with the wall is maximum, there will be no flow, or the velocity at the wall will be equal 0. And then the shear stress or the friction will be lower and lower when you go to the center of the pipe. Ya, jadi gesekan atau friksi layer itu akan semakin berkurang semakin lapisannya ke tengah. Or in the center, there will be no shear stress, no friction, and the velocity will reach maximum. I will not discuss the turbulent for now. Later, we will have the discussion. So the velocity profile, it means the profile of the U over R. R is arbitrary position inside the pipe, measured from the center of the pipe. Ya. Jadi R itu posisi sembarang di dalam pipa, diukur dari titik tengah pipa. Titik pusat pipa itu R-nya 0, R kecilnya 0. So at the center, R will be equal 0. At the wall, R will be equals this one. So the velocity profile will be depending on the position of R, depending on the viscosity of the water, and it will be depending on the pressure difference. Why there will be the, do you understand dP per dL? L is length of the pipe. It means there will be some pressure difference along the pipe. Why? From the friction. We will discuss it later in the friction, when we already discussed about friction, and how to get this formula we also will discuss. But from this equation, what you can see is the velocity of the, at certain position, velocity of the fluid at certain position will be depending on the position in radial position. R is radial position from the center of the pipe, depending on the viscosity, and will be depending on the axial position. Axial means along the pipe.
What is P again, sir? Is that pressure?
Pressure, yeah. Along the pipe, the pressure will be different. Why the pressure is different? Because the fluid experience friction. Okay, so maximum velocity means in the center of the pipe when R equals 0. So you replace it equals 0, then you get this equation. This is how you can calculate maximum velocity at the center of the pipe. But different position of the pipeline. Or you can also calculate the average velocity as half of the maximum velocity. Bisa paham ya? Jadi kecepatan di titik sembarang di dalam pipa itu nanti akan bergantung pada posisi radialnya. Posisi radialnya adalah posisi dilihat dari titik pusat pipanya, dari posisi aksialnya, posisi aksial itu posisi dilihat dari panjang pipa, jadi makin ke kanan L-nya makin besar, di titik masuk pipa L-nya 0 gitu ya, tapi nanti kita tidak bahas ini sekarang, nanti saja, karena akan ada perubahan tekanan. Selain itu juga akan dipengaruhi oleh viskositas fluidanya.
Sir, the dP over dL is negative because it's a resistive force, right? Yes, sir.
Because of what?
Because it's like friction force, nggak sih? Bener nggak, sir?
Because the higher L, if L increase, then the pressure will be decreased because of the friction. Yeah, the friction will the more the flow to the right, makin ke kanan alirannya, maka friksi yang dialami itu kan makin besar, right? So
Yes,
the
sir.
pressure will decrease. So the sign is minus. It means the velocity will decrease along the pipe.
Sorry, sir. The pressure due to what, sir?
Sorry.
I don't get why the pressure will decrease, sir. Is
Because,
it?
okay, later when we discuss about the energy mass balance, some energy will be converted because mass balance, energy balance stated that the total energy will be the same, right? So if you have some energy that the value is increased, in this type is in this context is the friction, because the more the fluid flowing to the axial direction, jadi makin ke kanan alirannya, maka gesekan yang dialami oleh fluida, the friction that experienced by the fluids is higher. The energy is higher. The friction energy is higher. It means we have to compensate with other types of energy that will be decreased. That's the pressure energy or the pressure. Seperti itu. Jadi karena makin ke kanan, gesekannya itu semakin besar. Gesekan kan mengurangi kemampuan fluidanya mengalir ya. Nah ini akan menurunkan tekanan. Sehingga nanti akan menurunkan kecepatan.
Okay, sir, I
I
understand.
think the concept is like that. But later when we discuss about the energy balance, there will be some cases when we can assume the pressure is constant, so only the velocity is decreased. Or when is the velocity is constant, so we can assume the pressure is decreasing. Nanti sambil jalan kita akan bahas. Okay. Now, how about the turbulent? This one, so if this is the normal ideal laminar, but the turbulent, actually there will be random pattern. Yeah, the one that I have shown you in the previous slide. But for example, if the turbulence, you can see there's some part, this is the example of the turbulent flow. Some part is, this one is called sublaminar. This one is the turbulent. So for the sublaminar, for the turbulent, you will have flat velocity profile. So in the turbulent, you can assume the full turbulent, or you can assume that there will be no differences in velocity. U-nya sama. But in sublaminar, there will be some effect of the shear stress. So there will be some differences in fluid velocity. How different and how to calculate? It actually depending on the system, depending on the fluid types. Fluid types mean the fluid density and the fluid velocity, depending on how big is the diameters, what is the material of the wall, and some others. So for example, ini nggak usah dihafal ya. This is some example of the empirical equation that can be used to calculate the velocity of the turbulent. This is empirical. It is based from the experiment. You just you variate the velocity of the fluid, and then you calculate how big is the diameters. For example, this is the sublaminar, then what is the differences between the core, turbulence, and the sublaminar. How is the height and something like that. This is the empirical equation. So do not need to derive or do not need to memorize this equation. Just example of turbulent flow. But for simplification, for turbulent, even though you see the profile is like this, for simplification, we can assume for turbulent flow, you will have this. So like for ideal turbulent flow, then you can take or you can assume that the velocity at any point of R, ya, mau di tengah, mau di pinggir, mau di agak pinggir, the velocity is same for turbulent. And the velocity will be average velocity. How to calculate average velocity? If you have, if you know the diameter of the pipe and the volumetric flow rate, how? So the average velocity will be the volumetric flow rate divided by A. A will be this one, right? So if the pipe is a cylinder shape, so you will know, if you know the value of the diameters and you already know the value of the volumetric flow rate, you just divide it. This is the value of average velocity, average linear velocity. Kecepatan linear. Kecepatan linear, the unit is this one. The volumetric flow rate, the unit will be this one. I'm using standard MKS unit. Okay, any question?
It's okay, sir.
Okay, now is the value. Actually, there is no strict borderline value for the Reynolds number, but you can assume that below 2000, you can classify it as laminar. Later, when we discuss about friction, we will not discuss it now. The pressure difference or pressure gradient, the dP over dL, it will be proportional to E, or it will be linear on laminar flow. But when the Reynolds number is 4000 or higher, then it can be classified as turbulent. And the dP over dL will be proportional to square Q. Nanti kita pas bahas friksi, akan ketemu lagi dengan hubungan dP per dL dengan Q. How about in between? In between, we call it transition flow. But sometimes people are using like this one is 5,000 or maybe 10,000. Maybe different books different. But normally, if already above 4,000, you can classify it as turbulent. What is the Reynolds number application? First, we have discussed to identify the flow regime or the flow pattern, whether it's laminar, transition, or turbulence. But later, also in this lecture, but in the next chapter, Reynolds number is actually can be used to calculate or determine what is called friction factor or friction in the fitting. When we connect pipes or we install valves, it's called fitting. Ya. Jadi alat-alat yang digunakan untuk menghubungkan pipa, misalnya ada elbow atau ada sambungan valve gitu. Itu namanya fitting. Later we will use Reynolds number to calculate this one. And also when we later discuss about the particle flow, then we can use the Reynolds number to determine what we call drag coefficient. Nggak usah dibingungin sekarang. Yang sekarang adalah yang ini. Oke? Cukup paham? Any question?
It's okay so far, sir.
Okay, then I'll stop the class for today.